All right, do you guys remember doing things like this? Like, do you know how to divide a fraction?
Yeah, you flip the sign.
Yeah? Okay, so you change the sign to multiplication, and then you do the reciprocal of the fraction. No problem, easy peasy. Then you just multiply straight across. Simple. Okay, so that's what we're doing right here. I mean, this thing looks so nasty, but it's just a giant division problem with two fractions. And so that's what we're going to do right now. Okay, so we're going to take the top one, and then I'm going to change this. Do I change it yet? Do I change it? No, I don't change it. Okay, but I make sure everything is factored. Okay, so the key, the trick is to make sure everything is factored so you can see common factors so you can cross them out. Okay, so we have x minus 5, x plus 2 for x squared minus 3x minus 10. And it's that because negative 5 and 2 multiply to give you negative 10. And then when they add together, they give you negative 3. And then we have division. That's what this giant fraction bar is right here. And then we have the bottom. We have x plus 2 on top. And on the bottom, I could take out a 3. All right. So let's do what we did up here. All right. Well, let's multiply by the reciprocal. So I'm going to rewrite the first one. Nothing changes. But then I'm going to change to multiplication and flip. Find the reciprocal of the second fraction. All right, so there you have it. Now, do you guys see any common factors that we can cancel? X minus 3, so let's kill them. Oh, wait, that was x plus 2. And then x minus 3. Dang, look at all those that got eliminated. So on the bottom, what do we have? Any numbers down there still? We have ones. Okay, whenever you cancel them out, they equal 1. In fact, that's why you could cancel them out. X plus 2 divided by x plus 2 is just 1. So now this is what we got, and this is your answer. This is what you would put in that guy right there. Okay, and then what the heck are these? Excuse me. What values of x must we exclude from the domains of the expressions? Okay, so this is what you have to do when looking for excluded values. You have to consider all the denominators. So here's a denominator, and then we got another denominator over here because we had to flip it, right? So we have 3 denominators. So what values of x would make these denominators equal to 0? Okay, look at this guy. I mean, it's pretty simple, isn't it? What value of x would make this denominator 0? 3. So 3 cannot be one of the values of x. So that's one of the excluded values. Is there a different one over here? No, this one's still 3, right? So this one doesn't make a difference. What about this guy right here? What about the last one? -2. Yeah, -2. You can't be -2. Now, if you weren't sure what value of x would make the factor 0, you just have to set the factor equal to 0. Now, this one, I mean, you wouldn't do this one because it's too friggin' obvious. Okay, you subtract 2, you get x equals -2. It's easy. Okay, but if you had like some crazy one, I mean, this isn't that crazy, but maybe you had one like this, and you're like, oh man, what value of x would make this equal 0? You just set it equal to 0 and then solve it. And so for this one, guys, this one I just made up. It has nothing to do with this problem. Okay, so you have 2x equals -5, and then x equals -5 divided by 2. This would be your excluded value. X cannot equal that. All right, question?
Why not?
All right, so, no, that was a great question. Okay, so -2 is another one of our excluded values because of that factor. Now, somebody asked, and I thought it was a great question, why not 5? I mean, that would make this factor equal 0. And the answer is, we don't care if the numerators are 0, because you can divide anything, you can divide 0 by anything. You just can't divide anything by 0. Okay, I mean, this is allowed. This would just be equal to 0, but I don't need to write that. Okay, so those are excluded values. Now, this one is a weird problem because the denominator switches right here. First, it was this guy, then it was this guy, and so you have to find excluded values for both of those denominators. At any point in this problem, wherever you have a denominator, we have to find an excluded value for it.